Okay, let's get started. So my name is Mridul Jain, and I'm accompanied here with my colleague, Junshi. We are going to talk about CaffeOnSpark updates. So most of you know that CaffeOnSpark was open sourced in Q1 2016 under the Apache 2.0 license. This is the first distributed deep learning open source software from Yahoo, and it supports GPUs as well as CPUs, and it works on Ethernet and InfiniBand. Now, this could be deployed on your private cloud very easily, and we have an EC2 image too. So before going into the talk, I just wanted to call out some of the noteworthy frameworks which have come up on Spark recently. TensorFlow in Spark was open sourced by us this year, and this follows the design patterns of CaffeOnSpark. It provides RDMA support, and this was contributed back to TensorFlow by June sitting here. Now, if you want to know more details about this talk, you can refer to the talk which was given yesterday in the same summit by Li Yang and Annie Feng. And they're sitting here, you can talk to them too. The second framework is Spark Deep Learning from Databricks. It enables TensorFlow inferencing via Spark MLlib pipelines. I don't think it supports distributed training yet on TensorFlow, but it is worth checking out. So in this talk, we are going to discuss use cases from Yahoo, some new features which we have added to CaffeOnSpark, and wrap it up with an auto-captioning demo on LSTMs. So we've been using deep learning at Flickr in production for almost 2 years using CaffeOnSpark. It powers search and magic view features of Flickr, and we recognize up to 2,000 concepts. And we also build photoaesthetic models. Now, Flickr Magic View is a product where you can upload all your pictures and all your camera rolls into Flickr, and it will auto-tag all those pictures with multiple categories. All the way up to 70 categories is what we recognize, like animal, architecture, food, landscape, and subcategories like fields, forest, mountains, etc. So for example, if you give rock in the search bar, you could surface all the pictures of rock in your photo album. NSFW detection is another important feature and important framework that we open source on CaffeOnSpark. And this is a very important piece of work because I don't think there's any deep learning library or any open source equivalent which exists for this. And we have open sourced not just the code, but we have also open sourced the model, ResNet 50 model. So you can actually use this for inferencing if you want and check it out kind of in your production or whatever. Yahoo eSports is another use case which is totally different, where we feed in videos of pro league game matches like StarCraft and other video games into CaffeOnSpark, and it auto-detects very important and significant frames in these videos. And these frames are later used to stitch together a highlight reel. If you want to know more about the modeling, there's a cool podcast link which is given here, and this, of course, will be shared. So it talks about how they went on thinking about these concepts and doing auto-detection. This is very impressive work. So before CaffeOnSpark, we used to do our distributed deep learning using multiple clusters. So we used to have Spark cluster, we used to have a deep learning cluster, and then we used to do a preparation of data sets and apply the inferencing on the Spark cluster and do our deep learning and testing on the deep learning cluster. And then we used to exchange the data between the two. So this was very unscalable, unmanageable, and difficult to work with. So we got CaffeOnSpark, where it uses Spark as the central cluster, which works on Hadoop datasets. And on the application stack, you can have CaffeOnSpark for deep learning, MLlib for non-deep learning, Hive or SparkQL, or many other things. So with this centralized system, we are able to address a lot of challenges in deep learning, specifically data and feature processing. Spark enables large-scale distributed processing. And we have this nice little beautiful DataFrames where we've added multi-label input support. You can also do model exploration and training with classical machine learning techniques and deep learning on the same Spark cluster. So you can, for example, have Caffe, and you can have MLlib from Spark and exchange the data between the two. So we have provided the APIs for the same, which is in Python and Scala. And we also have a feature called training with cross-validation, which I'll talk in a subsequent slide. Now, you can do distributed inferencing in Spark or in streaming Spark or on Storm on the same cluster. And this is very helpful for any kind of production launches that we do. So going into details of some of these features, first is DataFrames. So DataFrames is our primary data format, which we have supported in CaffeOnSpark from day one. Of course, DataFrame helps organize your data in very nice ways. It's a distributed collection of data in named columns. So you can have images, labels, etc. in DataFrames. And then you can feed all that to some kind of processing, some kind of training, and it can produce further DataFrames. Now, these DataFrames, initially, we used to have only scalar columns. But with the new feature called Unified DataLayer, which replaces the memory data layer, if people are familiar with that who have used CaffeOnSpark, we have now support for multidimensional columns. So for example, you can have a vector of labels or a vector of images. All of them can be represented and encoded in a data frame. And I'm going to show you this in a demo. Multi-label image support is another thing which we've added. So CaffeOnSpark initially did not support multiple labels for an image, but we know in machine learning most of the times that an image can belong to multiple classes, or you can have multiple objects being detected in that particular image. So for example, you can have predictions like animal, dog, pet, beach, grass, etc. So with this new unified data layer, we support multi-label per image too. Training with validation. So this is a very interesting feature which is very useful for a lot of data scientists. So whenever you're doing any kind of machine learning, whether it is classical machine learning, deep learning, or whatever, you run your hyperparameter search, you run multiple training jobs in general, and those can take days and weeks, all right? And you want to know, you come to know only how the model has evolved at the end of everything, at the end of the training. Now, what people want is, they want to know how the model is evolving as and when they are training, when they are conducting the training. So with training with validation in CaffeOnSpark, what you can specify is, for example, do 1,000 iterations of training, followed by 100 iterations of validation on your test data set on the model which has been produced yet, and then continue with 1,000 iterations of training again, so on and so forth, in an interleaved fashion. This really helps you recognize those jobs which are not going anywhere and just consuming resources, and you can kill them off if you want. CaffeOnSpark is now supported on Dockers, so we support both CPUs and GPUs. In addition to, we already supported Yarn clusters, EC2 clusters, standalone cluster mode, Spark. And this helps seamless deployment of CaffeOnSpark on multiple platforms. And thanks to Arun Das for contributing this. This is a major patch from the community, and this has really helped us promote CaffeOnSpark on multiple platforms. So now I'm going to switch gears and get into LSTMs, which are long short-term memory, which is one type of RNNs. And Caffe already supported RNNs long back, all right? Well, not long back, it actually added the support last year. And then soon after that, we added the distributed training support for LSTMs and RNNs. So RNNs and LSTMs are used for a lot of applications, and I'm going to discuss auto captioning here specifically and just show a demo of the same. So here you can see that if you have an image and if it is labeled with a caption, you can feed in that image and the label to LSTM. And after the training is done, if you feed an unlabeled image to the LSTM, it would produce a caption for that automatically. A totally unlabeled new image, it should produce a caption automatically. And we'll see a demo of this. Now, here you can see that there are two networks. One is a convolutional neural net, which takes an image and generates a FC8 or FC9 feature. And then you have the LSTM network, which takes that FC8 or FC9 feature, which is the representation of the image, along with a caption. And the caption is embedded into an embedding using something like this. You have a vocabulary, you have the words in the vocabulary, and you have the indices of those words. And for each of the words which gets into LSTM, you can represent that as a one-hot encoded vector. So CaffeOnSpark APIs already do this for you, so you don't have to do this. So all you have to do is provide an image, provide a caption, and all those embeddings are done by CaffeOnSpark APIs and fed to the LSTM, which you can just instantiate. We have APIs for those too. So let's look at an example of this using my Python notebook. Okay. So this is my IPython notebook, which is connected to the Spark cluster, which I was talking about. So whatever I run here runs on the whole Spark cluster. So first you do a bunch of imports. I'm not going to get into the details, but specifically point out important features. I will not do the training because that takes a lot of time. I already have trained models. So first and foremost, you load your image and captions, which are in JSON or simple JPEG images, into a data frame. You can use very high-level APIs on CaffeOnSpark, like Cocoa to image caption file, or image caption to embedding. These will automatically encode your image in the right format. If any kind of pre-processing needs to be done, it will do that. It will do one-hot encoding, which I was talking about, and load it into data frames. Once you have anything in a data frame, it's very easy to work with that. So you take that particular data frame and feed it to the first network, which is the CNN, which will produce an FC8 or FC9 feature. And those features, and of course, if you want, you can print out details of the features, which I have not done here. So once you have those features generated, you can feed it to LSTM network, and it will do the training along with the embedded caption and produce a model. Now, I have a model which I'm going to use for test purposes, which was already trained. This was kind of a model which I was talking about. So here I load in a bunch of images into a data frame using CaffeOnSpark APIs for test, which are unlabeled. And then I run certain predictions using a model which I have pre-trained with 95,000 iterations. So it runs in the Spark clusters and give me certain predictions. Let's see this in a better way using pandas. Okay, so so here are the images and the captions. So these are unlabeled images, and the machine has generated these captions. A man flying through the air while riding a snowboard, a man riding a skateboard down a street. Pretty impressive for 95,000 iterations, a kitchen with a refrigerator and a refrigerator. This is more to do with the language modeling, because language models work like that sometimes. If you give more number of iterations or less number of iterations, you will see different captions, and I'll just show you an example of that too. A man riding a skateboard down a street, pretty impressive. Not just in terms of that the caption is very relevant, just look at the grammar. That is machine producing everything by itself, each word by itself, right? So it recognizes a clock tower. Most probably the chimney was not in the captioning data set. So, whatever it could, it recognizes that. And sometimes, of course, it has problems too. So I don't know, it says a man holding a pizza with a plate, and holding a plate with a pizza on it. Although the sentence is correct, but I don't see a pizza. So now I ran this same examples with a different number of iterations, and it produces very interesting results. It produces a totally different caption, which is still very relevant. So if you look at this caption, a snowboarder is riding a trick on a snowy slope, which is quite different from this, a man flying through the air while riding a snowboard, right? This is just with different kind of iterations and different hyperparameters that you give. Maybe you run the network for a longer period of time. And most of these are different, but still very relevant. Each of them are very relevant. Here it says refrigerator and a stove. It recognizes that now. So here it got this wrong. So it was a man in the last one. And it gives bigger captions for this, but still doesn't recognize the first two towers. And I don't know what's the deal with this. It always gets this wrong. So a woman is sitting on a table with a dog, and I ran it and I tried to fix this multiple times. A person is holding a dog and a dog. So most probably, I don't know, there may be a dog in this picture, which the machine is able to see, which we are not able to. Or maybe it is talking about a hot dog, who knows? I don't know. Right? So this is the power of Caffe and CaffeOnSpark. You can do everything on a single notebook. You can actually load your models from HDFS. You can write it into DataFrames. You do not have to leave and copy data into clusters and move data around with your scripts and all that. Everything can be done from a single notebook. And we use notebooks for not just this example. We use it for a lot of examples that we do. We, in fact, have a platform which uses notebooks, and it's provided as a service. So you can do that, and you can actually deal with images. You can deal with any other kind of networks. And everything runs on the cluster, but you just have a single interface for doing the thing. And you can exchange the data between, let's say, I could have a third-party library or even Spark ML, and I can exchange the data between data formats. And I can do exchange with data formats here, right? So I don't know what happened to the display. Okay. Okay, so we just now saw a demo of LSTMs, and you can check this out. This data was used from Microsoft COCO dataset, which is a training dataset of captions and labels for what people are doing in the images. It's an activity dataset, and that's what we use just to demo this. So I don't have a lot more to talk about, and we can actually discuss more in terms of question and answers. But to summarize, CaffeOnSpark makes deep learning scalable. It is easy to install now with Dockers and EC2. It integrates easily and very seamlessly with your Spark pipelines, and you can do data exchanges very easily. If you have a Spark cluster, it's kind of a no-brainer. And we welcome contributions because we are planning to actually get into some advanced features like Caffe2 integration. So Caffe2 was recently released, and we would like CaffeOnSpark to be around Caffe2. And we will just get started on that work. Java APIs is something which the community wants, and they have actually raised so many Jiras around the same. If you want, you can contribute to that. And if you want to get into more advanced distributed training, like asynchronous distributed training, you can contact myself or June or any of these guys here. So that's all I have, and I can take questions. Yeah, June, come on.
So I had some questions about the LSTM, which may be off topic, but for one thing, when you're training, so you're training the image, so you're training the convolutional neural net on a different sort of label set than the LSTM, or am I misinterpreting?
No, it's the same label set. First, you take the images and you produce a feature.
Yeah.
I mean, CNN is just used to actually embed that into a feature, capture the image as a feature. That's
sure.
It.
So there's no training of the CNN by itself.
Not really. We're just extracting the features. Yeah, you would like to add that.
And then the other question I had is, do you have any way to capture a confidence level of a caption? So when we see a label like a woman holding a dog and a dog for plates of food, is there any way for the model currently to say, I have no idea what this is, so I just came up with something? Or
So actually we do calculate those things like confidence intervals, how many false positives, AUC curves and things like that. Yes, one of the interesting things is we don't have higher level APIs right now to do that, but it would be good to have that. Though when we did this particular experiment, we did see what are the differences. Inferencing right now is still not done in a distributed fashion. Only training is done distributed. But we would add higher level APIs for doing the same. You want to add something?
Oh yeah, I just want to say that the ImageNet, actually the CNN we train on the ImageNet first, and you get the model. And you take the model and put it into this LSTM. So then when you train the LSTM, the CNN was frozen. So it's you don't train it anymore. It's like given the weights, you just run through it. It's like in the inference mode. You get the features, and then you run through this. You train this LSTM. You get the LSTM the weights. That's how how we train this thing. So it's a two phases.
One of the interesting things is if you want, you can even download some of the models which are available for the CNN directly in the Caffe Zoo.
Yeah, a couple of questions. One was when we have GPU versus CPU, how much is the performance difference, and is it pretty drastic? And the second question was, how are you storing images and the attributes along with it in HDFS? Is it just HDFS
So
files?
what's the second question? Can you repeat that?
The second question was, how are you storing the images and the attributes within HDFS? Is it just a JSON file, or is it you're putting in some other system for that?
So first one you want to take?
The performance, you talk about the speed, right? I mean, the outcome should be the same. It just take longer on GPU, and actually the difference is pretty big. I think at one point we looked at like 5 or 10x difference. So the difference is pretty big. Second question.
Were you talking about the GPU, CPU in LSTM context or in general?
In general, actually,
Okay.
like
Okay.
yeah,
So
in general, I mean, do you have like specific nodes that were GPU focused to really divert all these kind of workloads into that, or did you just run into the CPU machines that Hadoop runs on most of the time?
So we have a GPU cluster and a CPU cluster, and actually we have comparison of some of these benchmarks on a blog, which you can see for CaffeOnSpark. So there, all the benchmarks are listed there. Coming to the second question, yes, the embedding is in the, not the embedding, the captions are in the JSON format. In fact, we load the JSON, and the images is just a directory on HDFS with the JPEG files. So you can, and the APIs will automatically take care and embed them into DataFrames.
Thank you for the presentation. I guess I have one point and one question. The point for the first guy who asked the question, there's a concept transfer learning with bottleneck features that you can get a trained model already on a CNN and just use it just to extract the features for it and then embed it and then run an LTSM on it. But my question is, I'm not a Caffe guy, I'm a TensorFlow guy, but I just want to know how much difference are we talking about CaffeOnSpark versus the Caffe on a local machine in terms of the features that are available and if mini batching is available or not?
How much difference between Caffe and CaffeOnSpark? I think CaffeOnSpark uses the Caffe as the platform, software to train the model and the inference. So it's based on the Caffe, but it has another layer on top of that so that you can use the Caffe distributed. So let's say you have a huge data set. You cannot put on a single box, and you want to have multiple GPUs to run, and even more than multiple GPUs, like multiple nodes. Each node has like multiple GPUs, and you want to train this kind of in this kind of distributed setup. And our CaffeOnSpark provide a method to do that. But you cannot do that with a single, the local Caffe.
No, I think I need to clarify. I understand that. I just want to know if all the features that Caffe on the local machine has available, say mini batching, LTSM, CovNets, all those things, are those all one-to-one transition on CaffeOnSpark? Do you guys have it available already?
Yes, yes. In fact, I think I don't know what training with cross validation.
Yeah, we have that as well. Yeah.
I think that is. I just talked about some of these features which were added to CaffeOnSpark specifically because these were available in Caffe and wanted to be 100% compatible in that sense, and some extra APIs that we have given. Of course, CaffeOnSpark has some extra just because of the distributed manner in which we work.
Questions?
I mean, we are working on a use case which is in ag industry, but I want to kind of like have a similar use case like that so that I'm not revealing the actual use case. So if you have like say a dog and the dog has a body shape in terms of its health conditions and whatnot, can you take a picture of the dog and see if that how many ribs are showing up if it is a short-haired dog or whatnot, and can it have that level of accuracy to really decipher the health of an animal from the images?
So if you have the training data set, definitely you can do something like that. It's a very interesting question. I don't know the real answer, but if you have training data sets, so I mean, this is no magic. Most of the deep learning is about supervised deep learning right now. So You can try if you have training well-labeled data set, things should work. Because one of the impressive things here is the activity data set, which is available from MS Coco. It's all labeled. All activities are labeled in that image. So in fact, it's available for videos too, because it's just an extension of images, right? So it works so well, and I didn't expect that. So it depends on, most probably as per whatever I can think of on your training data set and the hyperparameters which you choose, which you have to search by yourself.
And how many images usually it may need? Oh, yeah, sorry. Oh. Yeah, how many images usually is good to kind of like give a good result?
That depends on the problem. So for example, I know for NSFW, for example, the one which I was showing, we had trained on 200,000 images, right? All of them labeled. So for LSTM, I don't really remember how much the data was, because it's basically in terms of some GBs.
Thanks.
I mean, you can actually download this data set from mscoco.org, so you'll see exactly how much images do you need. We used all of that.
Are there any other questions? Yes.
I know it must be on everyone's mind, but just I'm curious to know what your thoughts were on Caffe versus TensorFlow for your experiences. I know it's been all over the web,
Yeah,
but
I know.
just your
so
take
the
on it.
TensorFlow and Spark team is also here. Caffe team is also here. And so who wants to go for that?
Okay, I will just comment on this. So it's, I think, mostly about user preference. So if you start using the Caffe, for example, you're happy with it, you stick to it. So you stick with it and you just use it. So that's happened to inside Yahoo actually. We have users like they want to use Caffe, so that's we work on this. We have this CaffeOnSpark, and then later on, some people say they want to use the TensorFlow, and we work on TensorFlow and Spark. It just most likely, depends on your project, I guess, and also your preference. I think both of them they're pretty much, the same functionality from my point of view. If you want to do like deep learning, I think either one will work. Just so you want to look at, let's say your data set, what kind of data set you have. Maybe some data set is easier to be used on the Caffe, and maybe because of previous work, the guy before you used the Caffe, you don't want to convert everything to TensorFlow, so maybe you want to use Caffe, this kind of thing.
Hey, Andy, do you want to add anything? From TensorFlow side.
I think June answered all the questions. I mean, from the Yahoo point of view, we developed both the framework and open source them. So our motivation was they tried to serving all the business needs of our data scientists. It's all, certainly there's other framework there, but I think, from our business point of view, at Yahoo, we are basically stick with TensorFlow and Caffe, and make them, those two are our preferred framework for our data scientists. At this point, I think we are quite happy with it, because both of them, ever since we released the framework, we have seen the adoption of the deep learning in our Hadoop cluster quite significantly. Thank you.
Another question.
This might be a stupid question. I'm wondering, like, when you do those Caffe TensorFlow in using a lot of machines, how do you handle the synchronization? Like, if one of the node is pretty slow, and do you let the Spark to handle it, or you use another way to handle it?
No.
Yeah. So for CaffeOnSpark, actually, this framework is synchronous training. So basically, if one node is slow, the whole process is slow. So the whole training will be slow. So that's unfortunately that's the feature I guess of the synchronous training. So we haven't done anything like asynchronous training yet. So I think the last slide you had if that's important, we can work on it. We can work together on it. And also, TensorFlow actually supports the asynchronous training. So if you really want to use it right away, you can try TensorFlow and Spark. that probably will fit your needs.
Any other questions? Thank you, gentlemen.
Thank you.
Thank you.